All right, so welcome. This is 2168, and so the advantage. So you guys are actually in a pretty good position because I actually teach 2 different lectures of 2168. I do. You may have noticed that there was an evening section as well, which is what I teach, and I record both the lectures. So you've got the advantage of being able to watch both because I do it slightly differently for each of them. Things to note that are in the syllabus that I went over in the syllabus video, but I should probably go over it anyway. I have office hours at 3 o'clock, so on Monday and Wednesday. And if you can't meet me then you can just shoot me an email, and I'm pretty flexible. Like here, I should be on campus until like 6-ish today, depending on when the trains leave. I'm pretty easy to meet with. Your TA's hours are slightly in flux right now because I have to update the syllabus slightly, which means I have to, make an adjustment to that. Let's see, what else is there to note? If you got a C in 1068, it may be advisable for you to, retake 1068 or try or review the material a bit more, because you can expect maybe anywhere between a 5 to 10 point drop. That being said, you'll have a pretty good idea of how well you're doing in this course way before the drop deadline. So around week 5, so this is week 1. Week 1 will be review. Week 2 will be assignment that has to do with lists. Week 3 will be our first timed lab, which will be 5% of the grade. You'll have 3 of those, and that sounds like it's super stressful, but it's going to be an easier lab to do than a typical lab. And the reason for this is that this allows me to draw a bunch of credit that would normally be eaten up by exams and move it out into a different field. So now the exams are worth only 15% as opposed to some monstrous amount. But so our third week, you'll get your first mini exam sort of, and then on around week 5 or 6 will be your first exam, which will cover pretty much chapter 2, and if we happen to get a bit further, maybe some chapter 3 and 4. But normally, what happens is that basically this lecture and maybe Monday's lecture will basically completely be that's just gonna be chapter 1, review of chapter 1, and who knows, maybe if I go really quickly, we can be done with that. Because really, chapter 1 is review of a lot of stuff, and the things that I'm not going to review then, I'm going to review as I come to them. So just to get a good grasp of people, because it was a long break, and we nearly froze to death, twice. So I drove back in that on the Friday. So I came, and there wasn't any snow the way I was driving. I went up Route 81. But it wasn't until Philly that I got to see how horrendous it was. And that was not last Friday, but the Friday before that. And that was interesting trying to find some parking at around midnight. All right, how many of you remember inheritance? Okay. Right, some of you doing this whole twitching hand thing where, yes, I remember I learned it, but if I were tested on it now, that wouldn't work, right? So, okay, and that's fine. That's perfectly fine. And how many of you remember encapsulation and and polymorphism? Don't worry, because we're going to review all that stuff today, because those are key concepts for data structures. So, and then I'll get into what a data structure is and what the data structures we'll learn. But first, we're going to start with a review before we actually get into what actually this class is all about. So let's go ahead and start reviewing. I'm going to go ahead and I program in Eclipse, but you can program whatever you want. Some of the UI stuff is going to be a bit small because I haven't adjusted the font sizes for the UI yet, because Eclipse and scaling don't go well together for some reason. That being said, you should be able to see the actual code I type in the back, and you should be able to see the console that I type in the back. So we're going to do so if you were in my 1068 class, and I do see some of you from my 1068, this is going to be a bit boring because you've seen this already. This is the animal inheritance lecture, and it's canned, but it works really well for explaining basically all the object-oriented concepts, which is why I do it so many times. So let me go ahead and let's see, destruct code. And you can find the links to all this code, by the way, on a GitHub link that's on the pages section of Canvas. So if you go on and log into Canvas, you should be able to see that you have that available. So let's go with new Java package inheritance day. You know, this mouse was working great, and now whenever I get into this room, it doesn't work great. I don't know what it is. Bluetooth mouse. All right, so new Java class. So we're going to start by working on the animal class. Okay, and what we're going to and so to remember what a class is. A class is a blueprint for writing an object, right? It's just simply it's just basically a representation, a model. You know, and we kind of use it as a blueprint to actually build objects. So objects are what we build using classes. So an animal is basically going to define an animal. So things that are important attributes about animals. I mean, for us, because we're humans, we like to classify things. So the name's pretty important to us. What's another important quality for an animal? What might define it?
Type of food it consumes.
Type of food it consumes. Not going to get that complex, but I heard color. Did somebody say color? Yeah. Okay. Color. So string color. I'm not going to go and make a string type, right? Sorry, color type, because I'm just going to keep it simple. String color and int size, because why not? I'm not going to mess with these other variables. I'm just going to mess with name, because that's really all the. But basically, as you think of things, you'll add them. Now there is a thing that I'm doing here that there's something I should be doing here, and that's I should make all these variables private, right? That's the entire idea of encapsulation. The idea here is that I don't want some other programmer to come in and change these variables without my explicit permission to do so, right? That's what encapsulation does. So first, it's kind of a double-edged thing here. First, it prevents you from somebody from accidentally changing something they shouldn't, but it also makes it simpler by hiding away information that other developers don't need to know about. So here, you know, everything is private, and you know the stuff is public. You know, and so we'll make our methods public. So remember, these variables are essentially they're nouns or adjectives, right? They're things that describe they're attributes of the animal. And what over in our methods that we're going to write for an object, they describe the verbs, the actions that we can perform with our object. It might have not been the metaphor that you learned in 1068, but it works just the same. The more metaphors, the better, I find. So I'm going to keep these super simple. Public void eat string thing, right? Right? So nothing too complex here, because what I'm trying to do is go over inheritance and polymorphism. So public string void eat string thing, and the way that's going to work is that we're just going to print out this dot name, and if you remember the keyword there, right? This dot name. This sets it says let's get this object, this instance of the object, his name attribute, and now we'll concatenate it with space eats the thing. Okay, and let's go ahead and do that. Add a period there at the end, and remember to concatenate. Okay, I'm going to go ahead and full screen this. Okay, so and also just remember, like in this context, because there's no other name variable, I can just say name, right? And it's referring to the instance variable. Remember, we have three types of variables in Java. We have our local variables, which are things like parameters, or if I created an int x5 over here, that's a local variable. It's just something that basically it's once it's the method or the code block it's in is done, we throw it away. Essentially, we don't need it anymore. They're kind of temporary things. Whereas the instance variable, that's an attribute that describes in this case, an animal. It's something that describes our object. So we keep it around. So it keeps it around. And we can access them using the this name. The last one, of course, is static variables, which are basically variables where we have a single copy, but it's shared among every single, every single object. So this name eats the thing, and the other things that animals do are, let's see, they move around. But since this is an animal, I probably should, and this can be any animal. We'll go ahead and yeah, sure, eats the thing. And for move, well, animals move in a variety of ways. So there's some fly, some swim, some run, some pounce, some climb, So I'm just going to say this dot name plus eats generically. Sorry, not in eats, but moves generically. Okay? And that's fairly straightforward. I mean, so let's go ahead and make our main method. I'm not done yet, right? But public stack, got to add constructors, but I'll get to that. Public stack void main string args, which is the magic phrase we learned to, create to run our program. So let's go ahead and do animal A is equal to new animal. And remember, I can get a constructor for free, right? If I don't define one, right? A.move. And what does it do? Well, it does a whole lot of nothing, actually. So that constructor null moves generically, right? What do you if you don't define a constructor, what it does is that it's just simply basically doesn't initialize anything. It's so like you didn't set up name, so it's null. You didn't set up color, so that's going to be null. You didn't set up size, so that's going to be not null because it's a primitive, but 0. It's for primitives, it will just set up a 0 value. Okay. So let's go ahead and work on this. Okay. So let's go ahead and create a single constructor, public animal, and it's going to go ahead and we're going to just say string name. So it's going to take in a name. Okay. And what we're going to do is we're going to say this name, the instance variable name, is equal to the local variable name. And visually we can tell them apart in an IDE because the IDE is kind enough to color them differently for us, right? If you haven't noticed that yet. In your IDE, be it NetBeans or Eclipse or whatever you're using, it's probably going to color them differently. Okay. If you're not in that, then the way you tell them apart is, well, one has this in front of it and one doesn't. And while this seems confusing, like why would you name them the same thing? It's actually kind of useful if you're creating a constructor that has like 12 variables in them, so you know which variable goes to which because they have the same name. So all you have to remember is just to always have this on the left side and name on the right. Okay? And we'll go ahead and say this dot color. And right, I didn't need to use this dot color, but I'm just doing it out of habit. Is equal to red. And int size, so not int size, but this dot size, because int size would create a new variable called size. Go to 5. So now we can pass it but of course I get an error here still, right? That says, hey, this isn't working for us because I tried creating a new animal without a parameter. But if I do this one and I call this animal Alice, Alice moves generically, right? Gets the name. So nothing too much going on there. Often, though, we have more than one constructor. Public animal, and a lot of times where basically if we don't create any parameters, we'll just have default values. So I could just copy this all over and do this. So this may be the first thing that you did not learn in Gen 68, right? So this is tedious, me going over here and copying everything and just plopping it right in here. And instead of saying this dot name is equal to that, I'll give it the default name of Andrew, right? Okay, that works now, and now it says, let's see if I remove this. Should be. But honestly, I'm lazy, and copying and pasting is just so much work. So instead, what we can do is that if we have a perfectly good constructor that we want to piggyback off of, we can use this again. We can use, say, this. And this looks weird if you haven't seen it before. So when we use this by itself without and just like use it as if though it was a method, because that's kind of what it looks like. It looks like I'm doing a method call off the keyword this. What this instance of this is doing is that it is calling the constructor, and I provided a single string. So it says, okay, I'm going to go and look for the constructor that has a single string variable passed into it. So if I control click on it to jump to where it is, notice it jumps to animal because that's the constructor for animal. Sorry, jumps to this constructor of animal because that's the constructor for animal that has a single string variable. So it will run, and it will say just pass this there and run this constructor instead, right? Because I'm lazy, and that keeps it nice and concise. And you can have constructors call other constructors. Now, if I recall, int x is equal to 5. Yeah. So it gives me an error if I'm doing something right here. It says that the constructor call must be the first statement in a constructor. So keep that in mind, right? You can't. It's this. It will stop you if you're messing up on this, obviously, right? You can't. And I think a lot of this has to do with like preventing yourself getting into some weird loop. So where you're just calling constructors all over the place, which would be terrible. Now we're also going to learn about the super keyword, okay? And we'll get to that when we get into our children constructors. But it works a whole lot like this. So I can use this to piggyback off of not just methods, but also so I can kind of overload a constructor in this manner, just like I would overload a method where it would create, right? And if you remember what overloading is, it's where I would do something like this, public void eat, and then so notice I have an eat method and an eat method, but one takes a string and one doesn't. And now, works like this now. This dot name wants to eat, but can't find anything, right? Right. So now if I don't provide a string, it has one behavior, and if I do provide a string, it has a different behavior. So a dot eat, let's be nice and give it something tasty. Right? Probably, hopefully not a human. Okay. Andrew wants to move. Andrew wants to eat, but can't find anything because it didn't take any parameters. And Andrew wants to eat something tasty. Right? So this is a class, right? It's got attributes, it's got constructors, it's got behaviors now. So, and the nice thing about Java is that it's an object-oriented language. So not only does it have this encapsulation thing, which prevents me from accidentally modifying stuff, right? Because I can also make my variable, I can also make pretty much anywhere I see public, it could be private instead. There are such things as private classes that we will probably get into. But, the idea here is that basically we only want them to be accessed, a certain way. Like my son who's about to turn 1-year-old, bless his little heart, he tried to feed me, but he tried stabbing me in the stomach with his food, and I'm like, no, that he can't feed me that way. That's private, Can't feed me by just trying to reach in and stout in there. You got to feed me through the mouth. That's the way, that's the way we're designed. So that's it, and it would be rather uncomfortable if we had to eat that way. So the point being is that, we have, and that's how it works for classes as well. We don't want somebody going in and doing damage that basically unintentionally. So that's encapsulation. It's basically twofold, preventing us from doing damage accidentally, but also making sure that we can properly, hide information so that it becomes less complex. They don't need to know about eat might be way more complex than this. They don't need to know about that. They just need to know if they provide a string to it, it will be eaten. So let's go ahead and review now inheritance, because we got to cover inheritance before we do polymorphism. So I'll go ahead and make the string. What we're going to do is that we're going to say reptile extends animal, and that what we're doing is that we're establishing a relationship between reptile and the animal. We're saying it's an is a relationship. We're saying a reptile is an animal, and again, the reason for this is because reptiles, they are an animal. We want to reuse all the code. Oh, well, we get almost all the code with a huge whopping exception. We don't get constructors, which I'll get into. And what we're doing is we get the, we say there's actually a type hierarchy chart. I believe saw it easily last night, but I'm not going to bother looking for it now. But there's a hierarchy chart that simply shows us that basically reptile inherits from animal, and animal inherits from object, right? If we don't say that you're extending something, well, everything in Java is an object, so we kind of just silently sort of just add an extends object here, because everything in Java is an object. Now remember, you can only extend a single class in Java, right? And why is that? Well, because there's a huge because there can be a potentially huge problem. So let's go to the board for a second. Okay. Right. So I'm going to show you why we only inherit one object by counterexample. So suppose we have a class A, which had a method foo, and a class B, which had a method foo. And then suppose we could extend both these classes. We've got C here that's inheriting both these classes. And now we create a C object and we run c.foo. Right? So the question now is, which foo do we use? They both have that. So we have two ways of handling this paradox. The first is to prevent this paradox from happening in the first place, which is the option Java went with. It says that you can't inherit two objects because we are trying to prevent this kind of madness from occurring. And the other way to handle this is coming up with a rule, which I think what Python does, which is basically saying, well, if it was C extends A, comma B, then we're going to go with A's foo. And if it was B, comma A, so if we extend foo first, so if we extend B first, we're going to go with B's, which is awesome, but can also lead to its own confusion, right? So, well, that's the reason. We're just trying to avoid some kind of destructive paradox, All right, so we can only extend one animal, but because reptile extends animal and because animal is a object, a reptile is also an object. So if I say reptile R is equal to new reptile, I'll learn how to type one of these days. Okay, reptile, and we do r dot, well, first off, we can do r dot eat. Andrew wants to eat but can't find anything. Okay, see? Let's see. And then r dot, let's see, toString, which we get from an object, right? Which right now will just simply print out so toString by default prints out a hash value, and the hash value by default is a memory location. So we say that toString prints out the memory location of it. So now, let's go ahead. So basically, though, we get everything except for our constructors. So I go reptile. So if I go reptile Ralph over here, it's going, you don't have a constructor for that, right? Because you don't inherit constructors from your parents. But wait, I was able to use this constructor, right? And it worked just fine. It printed out Andrew, which is kind of weird. So let's go ahead and, again, review what happens with constructors, okay? So what happens with constructors is, again, we do, if we don't define one, this is what, as far as you know, Java does, right? It gives you this one. Oh, that's weird, right? I didn't define anything, but it still says that Andrew wants to eat but can't find anything. That's kind of weird. Are we still running the same program? It says reptile 1 up here. We're not running animal, right? That's weird. What's going on here? Well, it's this thing over here that's implied. Super. So super for superclass. Okay. And notice that it doesn't change anything when I run super. So what super does is that it calls the parent's constructor. Okay, so this goes on silently behind the scenes. So super calls my parent's constructor, which calls the other constructor, right? So just like this, super has to be the first line so that there's no confusion over there. So what it does is that it calls my parent's constructor, which means that if I can call my parent's constructor, I can try doing it like this. So super Ralph, which will call my parent's constructor. Ralph wants to eat but can't find anything. That's cool, right? So I don't have to really write anything new for my constructors. I can just do, so let's go. So let me go ahead and just change the color of reptile to green, green because, we associate reptiles as being green. Yes, I know there's an error. That's kind of, oh, that's strange. Color, animal, oh, that color is not visible. Oh, that's strange. I thought I got everything by my parent if it wasn't constructor. Well, you do. But it's private, right? And when we say private, we actually mean private. We mean that no other classes, including our subclasses, can access this variable, right? Unless they've got a method that allows them to do so, right? Which is why we could see our name, because the eat method will let us see our name. But that seems really frustrating, because now I can't change, down here I can't change the color, okay? So fortunately, there's a solution for that, a different word for that we use a lot when we're inheriting stuff. Rather than making these variables public or private, we use something called protected, which is the only other, which I believe is pretty much the only other keyword you want to use. I mean, I think it's default technically. No, it is not. Okay. Protected, protected. Protected. And what protected does, it says it's private to my family. Okay. And by my family, I mean myself and all my subclasses. Not my parents. Myself and all my subclasses get this variable. They can see it and they can modify it. And now Reptile can change his color to green. Right? That makes sense to everybody? So protected is kind of this sort of half, it's kind of a, if public and private are absolutes, then there's a gradient that exists between them. And protected is closer on the side to private, right? Yes?
So is that better to use a get and set method?
I mean, we could use get and set methods, but this is basically if we wanted to do this for the constructor's sake. I mean, we could use get and set methods. I'm just avoiding doing so for the sake of simplicity right here. It's not so much better, it's just a design choice, because if you need to be able to modify your variables directly, then this is a way to do it. Because remember, in order to make a getter and setter, if you wanted to make a setter, it would have to be public, or it would have to be protected itself. So this kind of just doesn't beat around the bush. It just sets it to protected so that we can modify, so that our subclasses can modify it directly. Make sense? Because we still have the same design choice otherwise. If we, getting a setters and a getter, both public for variables, the same as having this variable public. Yes?
And the uses for making specifically protected methods, like ones that you only want to keep within your various subclasses.
I don't think I've ever written a protected method, but that doesn't mean there isn't a use for it. Okay, just because I haven't done it doesn't mean that somebody hasn't found a use for it, and that's just because I haven't gotten into the weeds enough with that. But this is a common enough case for protected. That being said, you're probably not going to use protected a whole lot. It's more of a you should know this. A lot of this is you should know this exists. You know it's and you know when you need to use it essentially. Okay, so the other thing we can do this pretty straightforward. So what this super method does, by the way, just to be clear, is that it runs this dot. So let me go ahead and this dot color. It runs the parent's constructor first, then it executes what we're doing. So if I print out the color before and after I set it in our own constructor, right, it'll go red then green. Make sense? Because it runs the parent's constructor first. We do a print line, which is really weird for constructor to have, but you can do that. Set the color to green, and then now the program's set up where the color is green. Okay. So we can also just do this. Also do this to make our I mean, we can also do something similar where we can do this.Ralph, right? And, you know, we can make this chained. So when we use the default constructor now, it calls the name constructor, which calls the parent's name constructor, right? So, I mean, yeah, that can be a bit annoying to follow. Let's see, what am I missing now? Duplicate. Oh, that's what I get for copying and pasting all over the place, right? Okay. So this calls the reptile with a parameter, which calls the animal with a parameter, and sets it up for us. Okay, doesn't normally get chained like that, and there's an argument for not doing that, which is the whole jumping with the code, right? But you know, the other argument is brevity, which wins out a lot of the time. Okay, so that's mainly be aware that super exists. The other important thing that we can do is that we can change behavior, right? Reptiles, they do modify their behavior a bit, right? So public void, so let's go with public void eat. So we're going to override the each thing method, right? So most reptiles, they've got pretty powerful jaws. So we're going to go ahead and say, rather than eating the food, we're just going to say they chomp on the food, right? So system.out.println this .name plus chomps on the thing. Started typing th and I immediately wanted to start typing this. So okay, so r dot. So first off, we have our overloaded eat method, and now we have our overridden eat method. Don't need an exclamation point there because it is a string. So Ralph wants to eat but can't find anything, right? It's calling its parent's method because it doesn't have one defined, so it just uses its parent's behavior. Ralph chomps on a juicy grub, right? Because it uses chomps on over here because eats this is overridden, right? So we always use the most specifically defined behavior. Okay, what else can we use? We can use and since a lot, let's not override move as well, because move, right, that depends a lot based on like how that lizard is built, or reptile is built, because some reptiles are lizards and they like scurry, and some are snakes and they slither, you know. So let's go ahead and actually build those classes too. So lizard, and I'm gonna just cheat a bit. So let's get our inherited constructors. So let's create constructors and create a main automatically for me. And I can browse and say I want my superclass to be reptile. Inheritance day.reptile, because I got to be able to inherit the right one. So it automatically created constructors for me. And what I'm going to do is that I'm going to say and all I'm going to do is say that the default name for a lizard should be Lizzie. So what is this going to do now? So lizard will pass, so the default constructor for lizard will pass Lizzie to the other lizard constructor, which will call reptile's lizard constructor, set the color to green. First it will call animal's constructor, which will set up all the stuff. Then it will set the color to green. And then if we have anything else after lizard, it will execute. So we execute basically from the top down. Okay. So now we've got Lizzie, a lizard, and what we're going to do is that we're going to override her move. So lizards public void move. system.out.println. And we could make a snake that extends reptile, but I'm going to just keep going on with this. Right, because more than one class can extend a. So you can have, you can have like any class can be extended any number of times. This dot lizard, sorry, this dot name plus scurried away. Okay. So lizard L is equal to a new lizard L dot move L dot eat L dot eat Okay, so now we're going to run this. L.move. Oops, Lizzie scurried. So let's go ahead and add a space. So Lizzie scurried away. That move was defined here. The L.eat wants to eat but can't find anything. That's not defined in lizard or reptile, but all the way up in animal, right? So it looks for it in lizard, can't find it. Looks for it in reptile, can't find it. Looks for it in animal. It says I can find the eat method in animal. Lizzie chomps on a nice bit of lettuce. Well, that's not here, but it is in reptile. So it's using methods from 3 different classes right now, which is pretty cool. And they're all things. A lizard can eat stuff like a reptile because it is a reptile. And we haven't decided to override that behavior. But it moves like its own thing. Okay? So that's inheritance. It allows us to reuse code and basically get more specific as we need to. We started out with very generic movement and very generic eating, but now we're much more specific. So, all right. So now for polymorphism. So polymorphism is kind of the idea that basically we can treat, since a lizard is an animal and it is a reptile, we can treat the lizard as both a reptile and as an animal as we need it. Okay? So as a result, that means that you can do stuff. So I'm just making sure that cancel. Please tell me that I forgot. Hold on a second. Oh, come on. I forgot to switch during that entire period to what I was recording to doing this. I did that last night too. So I need to really figure out a way to remind me to not do that. And the automatic switcher is not working for me. So, all right. So can you show me if you can just like if you can help me find the setting, then that would be great because I really need that. I was trying to look up a notification for that because again, I learned how I've been basically messing it around since Saturday. So, you know,
it's supposed to be like a recording flag on the side and just a split screen.
Yeah, I could really use that. So, let's see. Well, okay. Here's all the, well, I'll just run through what I have. Ta-da, ta-da. You can pause if you need to. Okay. That being, okay. So now with the, what we need is the polymorphism again. So animal A is equal to new lizard. So what's going on over here? So let's do this again with the web camera, but what I'm going to do at least this time is I'm going to leave this up and not switch to it. Okay. So when we create an animal variable, like we just did, we're creating a box, you know, labeled A because we said it was animal A. So this is this variable is you can kind of consider it a box that we are going to store. And what are we going to store in it? Well, whatever the type was. So we're going to store an animal in this. So we can do animal A is equal to a new lizard, right? And this works because from the story that we've just set up here, it makes sense that I can stuff a lizard into an animal box, right? A lizard is an animal, so a box meant for holding animals should be able to hold a lizard, right? That makes sense to everybody. Same with if it's a reptile. I can store a reptile in here. Okay? Now with, but it doesn't work the other way around for reasons that make sense if you think about it in the story we just set up, right? If I instead created a lizard box, right? A box specifically made for holding all sorts of lizards, right? And we called it L, and I went lizard L is equal to new animal. This gives me a compiler error, as I'm going to show you, because, I mean, this makes sense. I can't just take any random animal, like an elephant, and store it in a box meant for lizard. It's just not going to fit, right? Right? So you can store a more generic, more specific thing in a more generic container. So now let's switch back. So we can do this. We can also, but we can't do it the other way around. Lizard L is equal to a new animal, right? And remember, we're not actually also storing the actual animal object in there. What are we storing inside of a variable when we create a new object? Yes. Yeah, the memory reference, the location, where we're going to find it in memory. And this is because it makes it easier to bounce around and then send it from one object to from one method to another, since we can copy the memory location rather than copying the entire, actual object, which might be gigabytes. Okay. So animal A is equal to a new lizard, so we can put this in there. So why is this useful? Well, suppose I wanted to make a collection of animals, and that's what we're dealing with a lot this semester, data structures. We're dealing with collections of data. So suppose I wanted to make a collection of animals. The most basic collection we can deal with is an array. Animal zoo is equal to new, and if you have to look this up after a long break, don't feel too bad. I had to do that for like the first 2 years I was programming. So I'm making a animal array called zoo, which has 5 spots for animals, cages, if you will. So we have five exhibits in this zoo. So in the 0th slot, we're going to put we'll just go ahead and say a new animal. So just a new generic animal. In index 1, we're going to maybe say new animal with the name. Sorry, I got this only a couple of weeks ago, and I haven't done any really heavy coding on this laptop yet, and so still getting a bit used to the keyboard. And I'm going to use that excuse for as long as I can. Add the zoo 2 is equal to new reptile. Zoo 3 is equal to new lizard. Zoo 4, I'll make a new lizard. I'll make a new lizard. Lizard Leo. Okay? Okay, so now what we can do is why is this really nice? Well, the idea is that basically using polymorphism, when we're storing them, we can treat them like animals, but when we actually call the methods, it's going to open up this box, essentially, look inside and go, oh, it's an animal, oh, it's a reptile, oh, it's a lizard, and it's going to run the appropriate methods. So for int, we were able to do a lot without having this do a loop this lecture. That's pretty nice. For int I is equal to 0, I is less than zoo dot length, no parentheses, remember, for arrays, parentheses if it's a string, and with the collections we're going to be learning about this semester, we use dot size with parentheses, because because I was not, because, you know, made sense when they were designing it, even though it's confusing. And the reason is because some data structures don't have a length. Sets don't really have a length, but they do have a number of elements in them. So, zoo. So the ith. So we're going to have the ith animal eat food, and we're going to have the ith animal move. So now let's run it. So Andrew's an animal, so he eats the food regularly and he moves generically. Same with Ed the elephant. He eats the food and moves generically because we haven't defined behaviors for elephants. Ralph, being a reptile, he chomps on food and moves generically. Even though he's stored in an animal variable, right? He's a reptile, so he's going to eat like a reptile and he's going to move like a reptile, which we didn't define movement for reptiles, so they're going to move generically. Lizzie chomps on the food, which is how a reptile would do it, because that's what we defined lizards to do. Lizzie scurried away. Leo chomps on the food, and Leo scurried away. So it's very useful that we can just make a collection of all these animals and use them together. Okay, so let's see. The only other, so that's actually most of chapter 1 right there in your book. Now the book consists of 10 chapters, and I kind of just blazed through chapter 1 because a lot of it's a big review about like all those concepts. And now I'm skipping over some stuff like interfaces, which I'll get to very shortly. And that's just simply so I can get into the stuff and start talking about what data structures are, because it's actually easier to start talking about data structures when we're actually, talking about data structures. The one thing I do want to go over before is you may have dealt with you may have not seen wrapper classes yet, which is that sometimes you really need and we'll see why. Sometimes we really need we've got these primitives, right? And primitives are special in Java. Rather than storing a memory location in X, we just store the value 5 in X. But sometimes we really, really, really need that to be stored like an object. We need an object instead of a primitive. So we have these things called wrapper classes. Now you may have used it in a situation like this, where I go. So let me just comment these out. So system.out.println integer.maxValue, right? So integer is so first off, you may have seen a wrapper class like math, where it's just a collection of really useful things, like printing out the maximum value for an integer, right? And we can also do that for long. There's one for longs as well, basically for every primitive type. And the naming scheme makes sense. Like, you'll never guess what Boolean is, right? It's capital B Boolean as opposed to lowercase b Boolean. And here's like a bunch of stuff, like you can do logical OR, logical XOR, Boolean.true for the true value, right? Sometimes it's just useful. The only thing that's weird is character. Rather than being car, it's actually character fully spelled out. Nice. So there's just all sorts of things. So these are useful things. So you may have used it like this, just like you would have used the math class, a bunch of static methods and stack variables. Okay, but it also has another use, which is you can actually create new ones of them. But they work like string does, is that Java does a lot of work under the hood for you. So I can say int. So this is called autoboxing, where I take this variable and I just say int I is equal to x. And all it's doing is that it's automatically converting the primitive int to the wrapper class integer. The end result is that we can use these things interchangeably. Like if a method expects an int, I can pass in an integer. If it's expecting a integer, I can pass in an int. The only thing that doesn't work is like the automatic converting between ints and doubles. Right? That's the only thing that doesn't really work. And you'll notice, and you'll know why when that happens. Now, why do we need this? It has to do with something we'll learn called generics. I already have a video up online about generics, which was kind of a precursor to what I'm going to be doing now and on Monday. Assuming I'm here on Monday, which I'll get into in a sec. But that wasn't like, that's just an aside, as an extra supplemental video in case the lecture doesn't do it for you, because that was also me literally testing out, working with OBS to make sure it was a solution that could work, So you don't have to watch that, but do be sure to watch the video on the syllabus. Now, as far as Monday is concerned, so I have jury duty tomorrow.
No way.
So yeah, totally. I have no idea whether I'll be excused or not. But because I don't know how jury duty works in Philadelphia, other than it's like, oh, you serve for a day. And it's like one call, one trial. So basically, the idea is that you get that basically I think they try to move you into trial as soon as possible. So I don't know what the length of that can take. So worst case scenario, I'm not going to be here on Monday. So what will happen on Monday as a result, if I am not here, is that I will post a video, is that I'm going to do kind of a flipped lecture. Any of you familiar with that concept? Okay. So for those of you who aren't, though, a flipped lecture is kind of the idea where the idea is you do your homework at home. Flipped lecture says, no, you're going to do your homework in school instead. And what we're going to do is that your homework is instead going to be watch this lecture that I prepare in advance. And then we're going to turn this into an extra lab. And I'm going to maybe try experimenting that for a few things if I want to get an extra timed lab in or two, if I want to try to give you more timed lab grades, which makes sense. It's also a way for me to get more time to work one-on-one with each of you, or for you to work with your peers, which you should totally do. Yes?
Do we have lab this week?
We do have lab this week. Okay, so I will of course not be there, but you'll get a review assignment, and I'll try to, if I can't post a video that gives you I'm gonna see if I can't post something tonight, or if I did a video in the previous semester, because a lot of students have trouble with the organization of this, but it's basically gonna test everything that you've learned. But it's gonna be a little bit of a fun one. So let's go ahead and get into what are data structures? Data structures are collections of data. So they're basically a way of organizing a collection of data. Okay, and then there are the operations to modify that data and to access it. So they're basically this is a big class on organization. Which I am terrible at, so why am I the teacher for this? Well, because there's a lot of intricacy involved, and I do like getting into the weeds. So here's a list of all the things you're going to learn. You've already learned an array, or we're going to use that as kind of the building block, because you can argue whether that's a proper data structure or not, because it doesn't really have methods in Java. But we're going to start out with the list data structure, and that's chapter 2, which is going to involve most of the next couple weeks. We're going to learn about array lists, which are lists built using arrays. And then we're going to learn about linked lists, which are arrays built using links, surprisingly. Or references in this case. So, linked. What happens when I talk and write at the same time? So, list. So we'll learn array lists and linked lists. Those are two of the data structures. Next will be stacks and queues, which are chapter 3 and 4 respectively. Okay, chapters 3 and 4 will take about a lecture each to cover, because they're really just simpler versions of both array lists and linked lists. So you can modify them you can implement them in the same way you would do an array list, in the same way you would do a queue, but they're really simple once you've learned a linked list. Okay, then we'll learn about binary search trees. So we're probably not going to learn self-balancing. We're probably not going to learn any self-balancing trees. We might learn about them, what they do, but we're going to learn about binary search trees. We're also going to learn about heaps in the same chapter. Then we're going to learn about hash tables, my personal favorite chapter, and we're going to go over basically building sets and maps using hash tables, which are, I love these things because essentially, I love hash tables because essentially we're building really efficient data structures by cheating. And then finally we're going to cap it all off with graphs. Maybe I'll throw in a additional data structure or two, just so you can get exposure to more advanced material. But as far as the final exam is concerned, because this is a common final, this is what every other 2168 student is going to learn. So even if we learn additional stuff, additional data structures, you aren't going to be tested on those for the final. But we are going to, it's not just data structures also. We learn other material that isn't data structures. For instance, we're going to learn about big O notation and algorithmic efficiency, which I'll just denote as big O, which is how we measure how efficient stuff is. Okay. Also, before we can learn about binary search trees, we have to learn about recursion, because it's really painful to try to do binary search trees without learning about recursion. And recursion's extremely fun because we're going to use it to solve really, what we would consider really hard puzzles and really hard problems. We're going to turn them into really simple things. I did this last semester, but in class I'll be writing a Sudoku solver using recursion. So it's just a simple program that solves any Sudoku puzzle you throw at it. We're going to learn about classic chess problems that can be solved with recursion, as well as some other just classic problems. And yeah, they've been done to death for like 60 years, but they're still worthwhile to do, even if they haven't given out as homework assignments since like the 60s and 70s. The other things that we are going to learn are there's an entire one on sorting. So sorting, we're going to learn about, I'm going to teach maybe 7 different sorting algorithms in about a week. The exam will cover about 3, and then we're going to have a couple of different, a lab or 2 on that one, probably a timed lab on the sorting exercises. But this is what we learned this semester. There's a lot of stuff that goes into it, go into it, and we're going to start by learning about lists, array lists, and linked lists, and about big O notation. Okay, so first thing we have to talk about is what the heck is a list, and we kind of have, because that's the idea of chapter 2. So we kind of have an intuitive understanding of a list. I kind of made a list over here. But I mean, but at least one of you made a list. There's a good chance that one of you made a list. Not last Friday, the Friday before last, or Thursday or the Wednesday before last, when that big snowstorm was coming into town. You probably made a shopping list, right? So when a snowstorm comes into town, what are the first 2 things that go on the list?
Milk and bread. Milk
and bread, right? Because we totally should get a perishable item during an event where the power is likely to go out. I don't know why, but a lot of people get milk, bread, and then eggs for making French toast, because that's the thing. Right? This is a list, right? This is a list. Suppose, though, maybe it's maybe I should get some salt, right? So I can salt my steps so I don't trip. So that's important, so I'm going to put it at the top. So big thing in the list is that I can put stuff at the top, okay? I already have bread, though, right? So I'm going to go ahead and now erase this from my list, right? So that's another thing we like to do. We like to be able to add anything we want to our list anywhere we want. And we like to be able to remove anything in our list anywhere we want, right? So salt is the first thing, index 0. Index 1, index 2. Just because we remove bread doesn't mean this doesn't, this is the third thing in the list. We remove bread. It's not the 4th thing anymore. It's the 3rd thing, right? Right, so the indices and the positioning in the list automatically readjusts, right? Once it's gone from the list, it's gone, right? Makes sense. Let's see, so maybe some other stuff. So chips, maybe a 5-gallon of water, just in case the pipes freeze or something, So this is just stuff that you would want to pick up, right? This is a list. Most common operation, of course, is just adding something onto the end of the list. Right? So, and that's really what a list is. And you can kind of see how how an array can tie into here pretty well. The only issue with an array is that we have to adjust stuff, right? And manually adjust stuff. So let me go ahead and pull up / argue with the slides. So we do have the slides for the class, and they're already up. All 10 chapters are already uploaded online under the file section of there. So you do have access to all the slides for the class, because why not? Okay, and 5. There we go. What? I did. Thank you for the reminder, though. You know, making that mistake once makes me paranoid. So not paranoid enough though, you know. So again, I've got to figure out what that notification is. Maybe I'll go and yeah. I mean, well, I considered doing that where I extended the screen out there, but I prefer duplication because then you're going to be looking at my face in the corner the entire time, and I don't know, and that seems a bit weird. So all right, so this covers the list interface, and we'll go into interfaces if not today on Monday. Writing an array-based implementation of lists, that's the array list. Linked lists we're gonna learn 3 times over. Now your exam will most likely cover just singly linked lists. I've been doing that for a while though, and after 3 semesters of asking like very similar questions, I think I have to do a serious modification to what my actual exam is. So we'll see. Just simply because I got to keep it fresh, you know. I do hand my exams back to students, so you probably have a friend who's taken 2168, and you know. Doubly linked list we'll learn about, and circular linked list. And this one will be a big homework for you guys. I'm big as in like basically. So when I said basically you'll have a good idea of where you're going to be in the class. Like round 4 is where I give you basically the difficulty peaks around week 4 in terms of homework. Like not that the hardest assignment is given out, but basically everything else will be of lower or equal difficulty. Right? Nothing's not really going to be any harder than week 4 because week 4 is where you're still building up the finesse in order to do a lot of this stuff. The whole how do I work with references properly? Okay. So not saying that it's like super hard. I'm just saying that basically it's hard because it's new, right? All these things are going to be new, and that's where the difficulty comes. But it's newest at around week 4, if that makes sense. Okay. Big O notation and algorithm efficiency. So we will be doing you will be getting on week 3 you're having a timed lab and a math assignment. So your programming work will just be in the lab, and I'm going to be giving you guys a math packet, a worksheet to understand big O notation. So yeah, giving you math homework. Sorry, it's not too bad though. Implementing the list interface as a linked list, iterator. So a lot of stuff going over here. So they say a list is a collection of elements, each with a position or index, and that compares to what we have. Right. So you've got a collection of elements, each with a position or an index, and you have iterators that are these other objects that go through an object, and we'll learn more about that at the end of the chapter. It's a collection of elements, right, and they all have positions. Okay, array lists, linked lists, and abstract lists all are implement the list interface. Which how many of you did happen to learn interfaces in 1068? A depressing number of you. Okay, so in an index, so arrays, and when we say index structure, you know what that means because an array is an index structure. And you know that basically the important thing about an index structure is that you can either just grab an element out of the middle and look at it, right? Or you can go through it sequentially, right? You can do that, so you can like get the 3rd item in this list, which would be index 2, so that would be eggs, right? Or I could just go and read through the entire thing: salt, milk, eggs, chips, water, right? So issues with the array that you may have noticed, though, are that in Java, you can't change the length, right? You can't change the length. You can do that in Python because Python doesn't use arrays. It uses lists instead of arrays. Can't change the length. It's fixed when you create it. If you need to make room for an element, like you have extra space on the end, maybe you can move stuff over and put it in. And that's how an array list will work, right? But you have to manually move everything over in order to put something new into an array. And same with removing an element from the array. If you want to delete it, you have to shift stuff over. You haven't had to delete stuff from an array before. Okay, so Java provides what we call a list interface as part of its API. So basically that means that classes that implement the list interface provide the functionality of an index structure and offer many more operations. This simply means so what is an interface? Well, an interface, in the last 10 minutes of class, because that's actually quite enough time to explain what it is, a list interface is basically a to-do list for creating a list. Interface itself is a to-do list on writing a class. Okay, suppose So a good example is shapes. So an interface looks a heck of a lot like a class. It's got the same file type. So this is shape.java, but rather than putting down class, I put interface. So what's an interface? Well, an interface is a list of methods, and it says, and it ties in directly with inheritance, and it says if you want to be considered, if you want to have a is a relationship with shape, if you want to be considered a shape for the purposes of programming, then you need to implement the methods I'm going to list down. And as a result, these things are really easy to code. So what are things that we do with two-dimensional shapes? Well, that we care about. Public double get perimeter. Public double get area. And notice that these methods look slightly weird because I'm not doing any curly braces in them. I just end it with a semicolon, right? But this is actually all I need to do for an interface. What this says is that this is a, if you want to be considered a shape, then if you are inheriting from me, and we don't extend interfaces, we implement them, which you'll see in a second. If you want to be considered an interface, if you want to be considered an actual shape, you gotta basically essentially override these empty methods. And I literally cannot define anything over here. I can't. It gives me an error, not because I'm returning something, but because it says abstract methods do not specify a body. What the heck is an abstract? It's these things. So abstract is a keyword in Java. And if you're an interface, it automatically just adds the abstract keyword in. And that just simply means that you have to define, the subclass has to define these things. That's what you're saying. You're saying, I'm too lazy to define them here. I'm passing it off to my subclass. Or these are too abstract for my class to define, so I'm passing it off to a subclass. And I say class because you can have abstract methods in classes as well, but only in abstract classes, which are classes you can't build. I know that's a lot to take in. But it's just a matter to see the abstract. Let's see how this works, though, specifically by building the circle class. Circle is a shape. Okay, and the way we do this is that the circle, I like circles because they're the most basic shape. So rather than extending a shape, we say implements shape. Right? We implement an interface. And rather than, so there's a couple errors that cropped up, that's fine. I'll deal with that in a second. One thing to know about interface, though, we can totally implement more interfaces. So I can just make a list, which is another interface. Now that one's giving me a, and the reason we can implement multiple interfaces is, remember, the problem was, what if two things are named the same thing? Well, with interfaces, that doesn't matter because they're empty. So it doesn't matter if there's a conflict in names. They're empty. So we can implement as many interfaces as we want. We're just going to implement one. Notice it has an error, and it says that you have to implement these inherited abstract methods. Okay, I had Java just fill them out. So it simply says the perimeter, when you call get perimeter, return 0. Get area, return 0, right? That's not correct, but that's, for compilation purposes, that's what you have to do. They're implemented now. They're wrong, but they're implemented. Okay, so let's, with that out, but that's what it means. In order to for a circle to be considered a shape, it had to have these methods. That makes sense to everybody? So now let's, yes?
But how are, I don't understand how they're useful if you have to just rewrite the definition of the methods in the class anyway?
The reason they're useful is for polymorphism, because then I can create an array of shapes and iterate through them and get all the areas of different shapes, be it a square, a rectangle, or those. So I can collect them all together in a group. Basically, it's an organizational tool. Same thing with a list, is that I can consider, when we create lists, I can just have a list, and I don't have to know how the list implements it, but I know that if I do the add method for a list, it will add it to the list. It's also, it's a lot of compatibility it's just basically making sure that things will be compatible with each other. That's one of the big methods for it. Another reason for it is just mental organization. right? Mentally, you can make this to-do list of stuff that you need to write. So let's just finish off the circle class basically as simply as possible. One thing we can do in shape, though, that we can define, the only thing we can really define are final variables, right? Because those aren't going to change. 3.145. And so now, circle can use that. The only thing that defines a circle, unless we're like dealing on a two-dimensional plane, in which case we can extend this class and make a 2D circle, is the radius. So private double dprivate double radius this dot radius equals radius. Okay, so now for get perimeter, that's fairly straightforward to do. Return 2 times pi times radius. Okay, makes sense. And then for get area, pi times radius times radius. Okay, so that's cool. Now, if I were to make my own list, we're not only going to learn how to use the data structures. If it was just a class on how to use them, this would be a very short class. We're also going to learn how to write them from scratch, because that really lets us understand how they work and how to manipulate them when we do use them. Now, we're not going to write a Java list. We're not going to implement the list from Java. We're just going to write our own, because there's a lot of things to be covered in list. Right? Let's go ahead and implement the 23 methods to be considered a list. That's a lot of methods. You have a bunch of versions of add and add all. Right? We have all these methods, and we don't need to go over them because a lot of them are actually pretty trivial once you get some of them up and running. Like size is fairly straightforward. Like that's counting the number of things. But like other ones like is empty, which comes from, it's just something that's inherited. That's fairly straightforward to figure out. That's if the size is equal to 0. So a lot of these I'm just going to skip over for the sake of time. But if you wanted to make your own list that's considered a list by Java, you would have to implement all these things. Okay. Let's see. So that's all those. So but the overall idea is that the list, what we can do with the list is that we can get something from a list, we can change an item in a list, we can add to either end, remove, insert, traverse, and basically all of them will work. All of these classes the 2 classes we do here, the array list and the linked list, they do them, all these methods, but they do them very different manners. All right, so I think this is a pretty good cutoff point for this lecture. We have 3 minutes left, but whatever. If you've got any questions about this class, feel free to talk to me. I have office hours at 3 o'clock today, from 3 to 4. So every Monday, Wednesday, 3 to 4, you can find me. No appointment needed. You can just walk in. And other times, if you need to meet with me, just send me an email.